Building on the success of the Polaris spinal system deformity portfolio and the Trivium derotation system, Biomet introduces a revolutionary new technique for deformity correction called the DeRoduction system. This instrumentation platform combines powerful yet controlled rod reduction and vertebral body derotation capabilities in an intuitive and fully modular system. It embodies the next evolution of instrumentation focused on addressing complex spinal disorders. The following examples illustrate the unparalleled flexibility of the DeRoduction technique. After the anatomical landmarks are identified and pedicle preparation has been performed, the appropriate diameter and length pedicle screws are strategically placed. The appropriate length rod is selected and contoured to match the desired sagittal profile. Derotation helical flange plugs engage the top screws. The threaded rocket reducers may be used to align the rod, progressing in a caudad direction. Using hex end wrenches or rod grippers, the rod is rotated into the desired straight coronal plane orientation. The DeRoducers are securely attached onto the rocket reducers in one simple step. DeRotators are positioned on the contralateral side. The slots in the handles of the DeRotators and DeRoducers are aligned. Linkage rods are positioned in the innermost set of the slots in the handles. A comb is applied on the right thoracic curve and the left thoracolumbar curve. The spine is derotated by slowly rotating the clusters in opposing directions over approximately 15 seconds. With the desired axial plane correction achieved, cluster alignment rods are inserted to hold the correction in place. Holding a slight overcorrection will account for elastic rebound in the construct when instruments are removed. Derotation helical flange plugs are inserted and tightened. All of the instruments are removed. The rod on the contralateral side is positioned and the derotation helical flange plugs inserted and tightened. While traditional three-dimensional correction techniques have required rod reduction to be followed by vertebral body derotation, the DeRoduction technique enables the surgeon to select the sequence of vertebral body derotation and rod reduction. A series of rocket reducers are positioned and capture the rods within the large containment window. The proximal barrel can be rotated until the anvil makes contact with the rod. Using hex end wrenches or rod grippers, the rods are simultaneously rotated into the desired straight coronal plane orientation. Derotation helical flange plugs are positioned and provisionally tightened to maintain the desired coronal plane orientation. The DeRoducers are securely attached onto the rocket reducers in one simple step. The slots in the handles of the DeRoducers and DeRotators are aligned. Linkage rods are placed through the innermost slots in the handles, and combs are used to connect the clusters. The spine is derotated by slowly rotating the clusters in opposing directions over approximately 15 seconds. With desired axial plane correction achieved, cluster alignment rods are inserted to hold the correction in place. Holding a slight overcorrection will account for elastic rebound in the construct when instruments are removed. The rods are fully reduced by inserting the extended adapter through the DeRoducer and into the rocket reducer. Once the rod is fully reduced, a derotation helical flange plug is positioned and tightened. A vertebral horizontalizer instrument can be used to level non-level vertebrae, providing simultaneous single-level compression and distraction with no net spinal cord elongation. All of the instruments are removed.